So we are still in this video. We are going to resume kinematics. We consider equations of motion for uniformly accelerated motion. Right? Kinematics equations of motion for uniformly accelerated motion in a straight line. The motion is in a straight line. The motion is uniformly accelerated. So, but we begin with the definition of speed and velocity. Definition of speed and velocity. Definition of speed and velocity. Speed is defined as the rate of change of distance. Speed is defined as the rate of change of distance. Right? So speed is a scalar quantity. Said distance is a scalar quantity, so speed is a scalar quantity. Velocity is defined as the rate of change of displacement. The rate of change of displacement. So V is ds dt. S is the displacement, rate of change of displacement. Speed is simply equal to total distance over total time taken. So speed is a scalar, velocity is a vector quantity. So moving on to the definition of acceleration. Acceleration, it is defined as the rate of change of velocity. That is the definition of acceleration. So basically, acceleration A is equal to V minus 0 over t. This brings us to A, t is equal to V minus 0. So V will be U plus A t. So this is our. So V is the final velocity. V final velocity, U initial velocity, T time taken to an acquired change in velocity. So this would be our first equation of motion. V is equal to U plus AT is the first equation of motion. So now I want to derive the second equation of motion. I want to derive the second, third, and fourth equations of motion. So we're going to consider derivation derivations of second, third, and fourth equations of motion. So our derivations are based on the following approach. Right. An object with an initial velocity u, it accelerates uniformly over time t to reach a final speed v. So area under a vt graph is equal to displacement traveled by an object. So displacement there is equal to half. So this is a trapezium. This is a trapezium. So area in the trapezium is side A plus side B. So it's half u plus v times t, which is half u plus v times time. So our derivation is based on this approach of the fourth, second, third, and fourth equation of motion. So we have agreed that S is equal to half u plus v times t. Remember, v is equal to u plus at. So S is going to be half u plus, in case of u, I'm going to put u plus at times t, which is going to be half times t times 2u plus at. This simplifies to ut plus half at squared. So this is the second equation of motion, right? So we've just derived the second equation of motion. Now we're moving on to the third equation of motion. S is equal to half u plus v times t. V is equal to u plus at. So it means q will be v minus u over a. So S is going to be equal to half v plus u. This t will be v minus u over a. So we have S is equal to v plus u, v minus u over 2a. So this will be 2as is equal to v squared minus v squared. If you expand this bracket, so we have v squared is equal to u squared plus 2as. So this is the third equation of motion. This is the third equation of motion. So v squared is equal to u squared plus 2as is the third equation of motion. V squared is equal to u squared plus 2as is the third equation of motion. Now moving on to the fourth equation of motion. Finally, moving on to the fourth equation of motion. Again, from S is equal to half u plus v times t. We said v is equal to u plus at. So this means u will be equal to v minus at. So this will be S is equal to half u. In place of u, put there, you will put v minus a. Okay. V minus at plus v. So in place of u there, we'll put v minus at times 2. So we'll have half t 2v minus at. V plus v is 2v. So we'll have gt minus half at squared. So this is the fourth equation of motion. So S is equal to Vt minus half at squared, the fourth equation of motion. Now we're going to summarize. A summary of all the equations of motion. Let's
quickly go through a summary of all the equations of motion. A summary of all the equations of motion. The first equation V is equal to U. Get me? V is equal to U plus 80. First equation S is equal to UT plus half 80 squared. Second equation Z squared is equal to U squared plus 2AS. Third equation S is equal to 15 minus half 80 squared is the fourth equation. So the conditions under which these equations are valid. Conditions under which the equations are valid. 1. Motion must be in a straight line. 2. It must have constant acceleration. So the two conditions under which these equations are valid: 1, the motion must be in a straight line. Secondly, the motion must be in a straight line. So in our next video, I'm going to give you an exercise on the application of these equations of motion. Thank you.